Okay, so good evening, everyone. My name is Richie Heng. I'm a grade 10 student from Paragon International School, and today I will be teaching everyone 2020 grade 9 SASMO past papers. So yes, let's get started. So for the first question, I will give a few minutes for everyone to solve it. So you can have some time and do it. Yes. Sorry guys, I will share my screen very soon. Please wait. Okay, so we will solve the problem now. So in this question, you can see there's 2020 in all three parts like this, and this. So you can take 2020 as a factor of everything. So you'll get 2020 factor of 2020 minus 20 plus 1. So from this, you can just simplify the numbers inside the bracket. You'll get 2020 times 21. You'll get 404 2020, which is B. Okay, so we will. Sorry. Sorry. Okay, so is there any question or should we move on? Okay, so we will move on to the second question. So for the second question, can Li Xiang, can you read the question for us?
Which of the following value has the largest value?
Can you read like the values too?
A 2020, B 2020 to the power of 20 over 2020 to the power of 18, C 4080400, D 2020 to the power of 20 minus 2020 over 2020 to the power of 18 minus 2020, E option B and C.
Okay, so everyone, you will have a few minutes to do this problem. I'll answer this very soon. Okay, guys, so 2 minutes has passed, so we will start answering the question. So in this, they ask for the largest value between the 4 or 5 choices that they give. So for the first one is 2020, which is still 2020. For the second one, you will need to simplify it. You'll get 2020 to the power of 20 minus 18. You'll get 2020 squared, which is 4,080,400. For C, you'll get 4,080,400 like B2, and for D, you'll need to simplify it first. So to simplify it, you need to first factor out the same factor, which is 2020. From numerator and denominator, and you'll get something like this. And then after you simplify, you're left with this or this. So to continue to do this problem, you'll need to do like you add a value and you minus back that value. So from this, you will need to do like plus or minus plus and minus 2020 to squared to the numerator. So you'll get after this, you can break them into two fractions, which you will get 2020 to the power of 19 minus 2020 squared over 2020 to the power of 17 minus 1 plus 2020 squared minus 1 over 2017 minus 1. Then from in this, sorry, in this fraction, you can take out 2020 squared as a factor. So you'll get 2020 squared to the power of 2017 squared minus 1 over 2017 squared minus 1 plus with second fraction, it will stay the same. So as you can see in the first fraction, you can see that there's the same thing, 2017 squared minus 1 and for denominator and numerator. So you can just simplify it. And you're left with 2020 squared plus with 2020 squared minus 1 over 2020 17 minus 1. So from this, you can see that D equals to 2020 squared, which is the same value of B as B and C, plus with another value. So from this, you can say that D is larger than B and C. So from all the choices above, you can see that D is the largest value among all choices. So the answer is D. So is there any questions or anything? Okay, so I suppose there's nothing, so we can move on to our third question. I'll give everyone a few minutes to solve this, so good luck. Okay, so 2 minutes has passed. I would like to ask someone who is volunteering to read the question for us today. Okay, you can read, Ronan.
In mathematics, the product of the first n positive integers is written as n factorial equals to n times n minus 1 all the way till 1. For example, 2 factorial is equal to 2 times 1, and 7 factorial is equal to 7 times 6 times 5 all the way till 1. Find the number of consecutive zeros at the end of 11 factorial minus 10 factorial.
Okay, thank you. So from this question, they are asking for the numbers of consecutive zeros at the end of 11 factorial minus 10 factorial. So from this, from what they gave as an example, you can say you can write 11 factorial equals to 11 times 10 times 9 times 8 times to 1, or equals to 11 times with 10 factorial. So from this, you can replace the 11 factorial in the questions to be 11 times 10 factorials minus 10 factorial equals to 10 factorial. Factor with 11 minus 1 equals to 10 times 10 factorial. So in 10 factorial, you can expand it and you'll get 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So from this, you can see like there's only 5 and 4, where when you multiply it, you'll get 20. So there's gonna be a 0 at the end. And you will get, wait, sorry, hold on. Okay, so I'm sorry. So in the 10 factorial, you can see there's 2 pairs of 2 and 5, which is the 4, which you can write it as 2 squared. So there's going to be 2 pairs of 2 and 5 in its product. So you'll get in 10 factorial, there's going to be 2 consecutive zeros at the end and 2 zeros. And in this 10, you'll get another 0 here. So in total, you'll get 3 consecutive 0 at the end of the expression that they ask you for. So in all of the choices, there's no 3, so the answer is gonna be E. So is there any questions or anything? Hello guys, please respond. I'm scared.
No questions, no questions.
No
Okay,
question.
okay, thank
Matt Bong.
yes.
Chào.
Sorry, is there anything or no? If not, we can move on. Okay, so I suppose there's nothing, so we will move on to the 4th question. I will give everyone a few minutes to solve this, and we will solve it together very soon. Thank you. Okay, so we can start to answer the question now. Okay, okay, wait. Oh, okay. So there's someone who wants to go through question 3 again. I'm sorry, I didn't check the chat. My apologies. So, okay, we can go through this again. Okay, so from this, you can see from what the example they give you, you can conclude that for 11 factorial, you'll get 11 times 10 times 9 times 8 till 1. But 10 times till like the 10 times 9 times 8 till 1, you can replace it with 11 times 10 factorial. So, sorry. From this, you can replace the 11 factorial in the expression that they ask you. So you'll get 11 times 10 factorial minus 10 factorial. So from this, you can take out 10 factorial as a factor. Then you can simplify it. You'll get 10 factorial times with 10. So in 10 factorials, there's 2 pairs of 2 and 5. So 2 times 5, you'll get 10. So there's 2 pairs of it. So it means in 10 factorials, there's 2 0 at the end, times with another 10 outside of the 10 factorial, we'll get 3 zeros at the end. So from in the choices, there's no 3. So the answer is gonna be E. Okay, thank you. So we'll move on to the 4th question. So is there anyone who's volunteering to read? If no, I'll choose. Okay, you can read, Jingye.
Find the value of the following expression. 2025 times 19 factorial squared minus 5 times 19 factorial squared over 100 times 18 factorial times 20 factorial plus 18 factorial times 20 factorial. Thank you.
Okay, thank you very much for reading it for us. So we can start to solve the question now. So in the numerator, you can see there's 19 factorial squared in both expressions. So you can take out 19 factorial squared as a factor. So it's going to be equals to 19 factorial squared factor of 2025 minus 5. While in the denominator, there's 18 factorials times 20 factorial in both sides of the addition sign, this one and this one. So you can take it as a factor. It's gonna be like this. And then you can just simplify it, and you'll get 19 factorial squared times 20 over okay. So from this, from the first like here, 19 factorial squared, you can write it as 19 factorial times 19 factorial times 20 over 18 factorials times 20 factorials times 101. So from here, you can hold on, let me change this. Okay, so from this 19 factorials, you can write it as 19 times 18 factorials, like what we did up here. And for this 20 factorials, you can also replace it by 20 times 19 factorials. So you can just replace both the value back inside. You'll get here you'll get 18 factorials times 19 times 19 factorials times 20 over 18 factorials times 19 factorials times 20 times 101. Then you can simplify. You can simplify this, and this, and 20 times 101, you'll get 2022. So you can just simplify that too. So the answer, you'll get 19, which is A. So is there any questions, or do I need to go through everything again? You can type in the chat if you want. You can type in the question. Hello, Moni, you can, where do you get, okay. So where did I get this one, right? So, hold on, let me choose a different color. Okay, so from the numerator over here, just look at this numerator. You can, from both sides, you can see there's 18 factorials times 20 factorials, which is the same thing. So you can factor them out, or you can just factor them out one by one. So if you do it one by one, you'll get 18 factorials factor of 100 times 20 factorials plus with 20 factorials. And then you can take 20 factorials out again. So you'll get 18 factorials times 20 factorials to the power of factor of 100 plus 1. So did I answer your question? Moni, you can type in the chat. Is this okay or you need further explanation? Okay, I suppose it's okay. So we'll move on to the next question. Oh, what is this called? I thought I understand its meaning, but I don't know. Okay, so it's called factorial, like that. Where did 2020 go? Okay, so from here. So over here, there's it's gonna be 20 times 101 times 2020. So if you calculate this one, this value, 20 times 101, you'll get 2020, and you can just simplify them since they're in like the numerator and the denominator. You can just simplify it out. Do you get it? Okay, so I suppose it's done. So we can move on to the next question. I'll give everyone a bit of time to think and suffer. I'll be back very soon. Sorry. Okay, so I suppose everyone has done this a bit, so we can solve this question now. So for question 5, they ask which number below is a factor of 91 to the power of 4 minus 1. So in this problem, you need to know a formula, which is a squared minus b squared equals to a minus b times a plus b. So from here, you can just you can just rewrite the expression that they gave you to be 91 squared to the 91 squared to the squared minus with 1 squared. So you can just do like the formula above. You'll get 91 squared minus 1, 91 squared plus 1. And if you knew, like, you can just calculate for 91 squared and minus 1 plus 1, you'll get 82, 80 times with 82, 82. So from this, you can just find the factor of each. So 82, 80, you'll get 20 times with 414, and 82, 82. You'll get 82 times with 101. So from this, you can just rewrite it all over again, but without the brackets. Okay, and from here, you can see that for, hold on, for this and this, as like what we know from above, 20 times 101, you can just rewrite it first, and then this. So 20 times 101, you'll get 2020. And for the rest, you can just replace there again. So from the choices, you can see that there's only B that matches with the factor that we found. So the answer is gonna be B. So is there any questions or anything that I need to repeat? If no, we can move on. Or is there anyone still have any questions? Can you repeat? Okay, so the formula is over here. A squared minus B squared equals to A minus B and A plus B. But for the expression that they gave us, it's to the power of 4. So we can just rewrite it into this way, like what I just wrote. 92 squared, 92 squared, and then squared again. Because you can just, like, it's like a formula for that too. Like A to the power of B and then to the power of C. You'll get A B times C. So 4 equals to 2 times 2. Or you can just write this 91, 2 times 2, and you can just replace it with 91 squared and then squared again. In the exam, we are not allowed to use calculators, but for 91 squared, you can just simply calculate it using normal operation. Like, yeah, just normally calculate it and you can get the answer by just -1 or +1 at the end. For this, we expand both of them. So like for 80, 82 and 80, 82, 80, we can just here we like we find a factor of it. You'll get 20 times 414, and for 82, 82, you'll get 82 times 101. And then after that, you can just remove the bracket, and you can see that there's 20 and 101. And from the above, we know that 20 times 101 equals to 2020. So you can just put them together and we can just multiply that them both together. And you'll get one factor of it is 2020. Oh, okay. So it's actually like no trick. You can just guess that out, but you can just try to like do the prime factorization for it, which is kind of big. Or if you don't want to do it, you can just like you see here for 91 squared here. It's like also goes into the formula above. So you can just use the formula above for that. You'll get 91 minus 1, 91 minus 2. Then you'll get 90 times 92. And from this, you can just like expand them both out using prime factorization. And you can just like put them both together. It's like not really a trick that you need to know. It just depends on how you will like divide that number with. So from this, I just divided by 20 and I got 20 times 414 like that. Okay, so I suppose there's no more questions. We can move on to the next question. So I'll give everyone a few minutes to solve this on your own, and we will solve this together very soon. Thank you. So like in this problem, there's a keyword which is co-prime. So co-prime is like when you find the highest common factor of two number, example A and B, it's equals to 1. So like A and B doesn't have a common factor which with each other. So it's called a co-prime. Okay, so I think we can solve the problem now. So is there anyone who is volunteering to read the questions for us? You can raise your hand. If not, I will call you. Okay, so Monica, can you read it for us?
What was the question again?
Can you read the questions for us?
Okay. What is the smallest positive integer that can be expressed as a product of 6 positive integers such that any 2 of them are not co-prime?
Okay, so from what I explained, co-prime is when the highest common factor of two numbers equals to 1. So it means that both of the numbers are prime to each other. So they ask for the smallest positive integer too. So this is another keyword for us to know. So to find the smallest positive integer, you will need to list out the smallest, like the small numbers first. So we can use it as the idea to get the number. So the smallest, like the first 5 number, you'll get 1, 2, 3, 4, and 5. So for 1, you cannot take 1 as one of the factors because 1 is co-prime to every positive integers. So then we can use 2. And for 2, and like in the problem, you need to know that hello. Okay. So each of the problem, you need to know that they did not mention us that we can only use one, or we can use one number more than once or not. So for this question, you can use one number more than one. And just like what I stated before, the smaller one is co-prime to every number. So it means that every like all of the 6 factors, or like the product of that 6 like 6 numbers that we're gonna take it is gonna be more than 1, and it can be the same number too. So the next number that is a bit more than 1, which is 2. So from this you can just take 2 times 2 times 2 times 2 6 times, and you'll get 64 for this 64 as the answer, which is B. Is there any questions? You can type in the chat. Okay, so I suppose there's no question. We can move on to the next question. For this question, it's gonna be the last question of today, as our session it's only 1 hour. So please take your time to solve this question. Thank you. Okay, so we can start to solve this question now. So in question 7, there are 4 friends that have accounts on some social networks, any two of them use at least one common social network, and no social networks are used by more than two of them. At least how many social networks are used by the friends? So first, we can label the friends, like the 4 friends, with A, B, C, D. So in the first statement, they say that two of them, like any two of the friends, must use at least one common social network. So example, A and B will use one social network, and C and D will use one common social network. And for the second statement, they state that no social networks are used by more than two of the friends. So it means that one social network, example, social network number 1, it can only be used by 2 friends, not 3 or 4. So example, AB will be using the first one, and CD will use the second one, and BC can use the third one, like that. So from this, we can just do like friends A. Since all of them have one common social network, you can say that A is connected to B in the first social network, connected to C, D in the second and third social network. And for B, he or she connect to C and D with the fourth and fifth social network, while C can connect to D on the sixth social network. From this, you can see that the reason that I didn't put A in B, because you can already see that A and B are already linked in the first one, and so does for a C to D. I did not put A and B in the C because it's already linked to each other in the first two already. So from this, you can see that there's that they use a total of 6 social network, which is C is the answer. So is there any questions that I can answer? If there's any question, you can type it in, or you can just open your audio and talk. Okay, you can please write out the question. Yes, this Zoom class will happen every weekend, while for grade 9, it will happen only this week, the 2nd, 9th, and 16th, and 23rd. So for a total of 4 weeks. So if there's no other questions, you can, if there's any other questions that you don't have it right now, you can just ask in the group or in the chat right now. But if you do not, we can end this class now since it's already time. Okay, so I suppose there's no more questions. I'll end the class now. So you can leave and enjoy your evening, enjoy your night with your family. Thank you for joining our Zoom today.